Alright, so let's take a look at the solutions to question number 1. So we want to find the derivative of this function, the inverse sine of log base 3 of 2x squared plus 1 over cosecant 4 to the x to the third plus x. Okay? And we do not have to simplify. So if you notice, we have a quotient of two functions here. So we're going to have to use the quotient rule. Okay? So to refresh our memory as to what the quotient rule is, let's go ahead and write that down. Quotient rule is if you have a quotient of two functions u over v, and you want to find the derivative, u over v prime is vu prime minus uv prime over v squared. Okay, so that's the rule we're going to use. In this problem, the numerator is going to be u, and then the denominator is v. Okay, so now that we have u and v, in order to be able to apply the quotient rule, we simply need to find u prime and v prime. Okay, so u is a composite function. U is composed of three functions: the inverse sine, the logarithmic function, and your quadratic function here. Okay, so if u is basically inverse sine of log base 3 of 2x squared plus 1. Now let's call it, let's u be f of g of h of x. Okay, let me shift this to the side a little bit. So u is f of g of h of x, and then that's basically the inverse sine of log base 3 times 2x squared plus 1. Okay, so what we're going to do is we're going to decompose this function, and then we're going to use the chain rule to find out what the derivative of this function is. Okay, so let's go ahead and decompose this function. The outermost function, let's call that f, since it's f here. So this is f of x. We have f of x is equal to the inverse sine of x, and then the inner function is going to be g of x. Actually, it's g of h of x. This entire function right here, we're going to call it g of h of x. And g of h of x is log base 3 of 2x squared plus 1. So since this is made up of two functions, let's go ahead and decompose that again. So we're going to take out the middle function. The middle function is g of x. So in this problem, g of x is basically log base 3 of x. And then the innermost function is h of x. Okay, so h of x is 2x squared plus 1. All right. Okay, so now that we have decomposed the function, we're going to use the chain rule. So if you're looking for the derivative of three functions composed in this fashion, what you're going to have, u prime is going to be the derivative of f of g of h of x prime. So what is that? That's going to be the derivative of the outermost function evaluated at the inner function, evaluated at the middle function composed with the inner function, times the derivative of the middle function evaluated at the innermost function, times the derivative of the innermost function. Okay, so that's how that's the formula that we're going to use to find the derivative of three functions composed with one another. Alright, so all we simply have to do is find the derivative of f, g, and h, and then we're going to compose them with their respective inner functions, okay? So if f of x is inverse sine of x, then the derivative of that, f prime of x, is going to be 1 over the square root of 1 minus x squared. If g of x is log base 3 of x, then g prime of x is going to be 1 over 1 over x times the natural logarithm of the base, which is 3. If h of x is 2x squared plus 1, then the derivative of that h prime of x is simply going to be 4x. Okay? So now to put it back in this chain rule formula, all you're simply going to do is take g of h of x and compose that with f prime of x, and then we'll take h of x and compose that with g prime of x, okay? So the combination of these two is f prime of g of h of x. The combination of these two is g prime of h of x, and then we just multiply by this last piece here, all right? So let's go ahead and put that together. So we're going to have f prime of g of h of x is going to be 1 over, this is the wrong line, 1 over, let's see, what is g of x? Okay, log base 3. So 1 over the square root. So we're going to have a square root. Instead of 1 minus x squared, we're going to have 1 minus log base 3 of 2x squared plus 1. Now that's square, okay? So that's f prime of g of h of x. And then g prime of h of x, we just plug in h of x into g prime of x here. So times 1 over, instead of x ln 3, we're going to have 2x squared plus 1 times the natural logarithm of 3, ln 3. Okay, so that's g prime of h of x. And then lastly, h prime of x is simply 4x. So that's, this is u prime. Okay, so we have u prime. Next thing we want to find is v prime. So let's look at what v is again. V is also a composition of 3 functions: cosecant, an exponential function, and a cubic function. Okay, cosecant 4x to the third plus x. So let's go ahead and write that down. So v is f of g of h of x, which is cosecant 4 raised to the x to the third plus x. Okay, so here, let's go ahead and decompose it so we can use the chain rule. F of x is the outermost function. So f of x is cosecant x. And then the inner function, inner composite function, g of h of x. G of h of x is what you have when you take away the cosecant, which is 4 raised to the x to the third plus x. All right, let's decompose this into g and h. So g of x is the exponential function, so let's extract that. G of x is equal to 4 to the x. And then h of x is the innermost function, which is x to the third plus x. All right, so we know what the derivative is. V prime is equal to f of g of h of x prime, which is the derivative of the outermost function evaluated at the composition of the middle and the innermost function, times the derivative of the middle function evaluated at the innermost function, times the derivative of the innermost function. Okay, so this is the chain rule for three functions. Alright, so all we have to do is find the derivative of these decomposed functions and compose them back with their respective inner functions, okay? So f prime of x, the derivative of cosecant, is negative cosecant x cotangent x, okay? And then the derivative of 4 to the x, which is g of x, so g prime of x is going to be 4 to the x times the natural logarithm of the base, which is 4. And then the derivative of h prime of x is simply 3x squared plus 1. All right? So to reassemble them back together, we're just going to input g of h of x into f of x right here. And then we're going to input h of x into g prime of x, that's basically this x right here, and then we multiply it by this, okay? So when we're inputting g of h of x into f of x, there are two x's, so let me be more specific as to where I'm putting it in. I'm going to be putting one here, and then I'm going to take it and put it there. Okay, that's what I mean by composition. And then h of x goes into this x right here. Okay, so let's go ahead and finish this off. So we have f prime of x, f prime of g of h of x is going to be, I'm going to need some space here, so it's going to be negative cosecant x, which is 4 to the x to the third plus x, negative cosecant x cotangent of g of h of x again, which is 4 to the x to the third plus x. So that is f prime of g of h of x. G prime of x is going to be 4 to the, instead of x, we have x to the third plus x ln 4 times h prime of x, which is 3x squared plus 1. Okay, so that's v prime. All right, so now we have u prime and v prime. We're just basically going to put everything together to write down our final answer. Okay, so back to the quotient rule. Let's rewrite it again so we can keep track of what we're doing. So the quotient rule is u over v prime is equal to vu prime minus uv prime over v squared. Okay, so our derivative is going to be, we're going to need some space here. So v is the denominator, right? So the denominator is cosecant x times 4x to the third plus x. Okay, let's go ahead and write that down. So v is cosecant of 4 raised to the x to the third plus x. That's v. And we're going to multiply this by u prime, okay? So u prime is this, where's u prime? This is u prime right here. We can put it together so it looks nice. So we just multiply v by u prime. So u prime is is 4x divided by, we can put the denominator together, so divided by the square root of 1 minus log base 3 of 2x squared plus 1, close that, and that's square, times, let's just extend that a little bit, times 2x squared plus 1 times ln 3. Okay, so this is v, yes, is v times u prime. Okay, so we have v times u prime minus uv prime. Okay, so we know what u is. U is the numerator right here. So u times the derivative of v, and v prime is the last answer we got. So this is v prime right here. So let's go ahead and write that down. Okay, so I moved this to the left a little bit, and I put v, I multiplied it by the numerator just to make space for the second part of the numerator. So on the right side, we're going to have uv prime. So we know what u is. U is the numerator, and that is the inverse sine of log base 3 of 2x squared plus 1. Okay, and then that will be multiplied by v prime. Okay, so I'll put v prime in here. So this has a minus, so we can multiply this and make that a plus. Let's shift this to the right a little bit so that we have enough space. All right, so make that into a plus, and then let's put in v prime to the right. Okay, so v prime is going to be cosecant 4 to the x to the third plus x, cotangent of the same thing, 4 to the x to the third plus x, and then that multiplied by 4 to the x to the third plus x, ln 4, and then times 3x plus 1. Okay, so times 3x squared plus 1. Okay, just make it fit like that. All right, so this is vu prime. So vu prime times uv prime. Well, v prime does u and v prime. Let's see, u and v prime. None of them have a denominator, so I don't even need the denominator part here. So that's uv prime all together here, and then just put that over there. So that's uv prime, and then we'll divide our result by v squared. Okay, so we know what v is, right? V is the denominator. It's right here, cosecant of 4 times x, 4 raised to the x to the third plus x. So v squared is simply going to be cosecant square of 4 raised to the x to the third plus x. Okay, and that's the derivative of the original function. You don't have to bother simplifying. I'll just leave it like this, and that will give you full credit. So that's that.